Okay, this is a unit that features a lot of algebra, and in this section we're going to get quite a bit of vocabulary and the definitions of a lot of vocabulary involving polynomials. So let's get started. First of all, a variable. And a variable is basically a letter that stands for a number, or more specifically, a letter whose value is an unknown real number. And we can bring back those symbols that we learned in an earlier unit. For example, you could have X or Y or A, or you could use some different Greek symbols, theta, phi, lots of different things. Usually we use letters like X and Y or A or B. Okay, the next concept term is actually called a term. And a term can be one of two things. It can be a number, or it can be the product of a number and some variables. And specifically, those variables can be raised to a power. So you can just have the number 5 or -8. Those can be terms. Or you can start to involve some algebra. So you can have 1x, you can have -2y's, and they can be raised to a power. So this is x to the power of 1, this is y to the power of 1. You can multiply things together like xy, that's x to the power of 1, y to the power of 1. Or you can have something like 3x squared or -10x to the 5th. Just by simply raising the variable to a power, you quite drastically change what the term is. All of those are definitions or examples of terms. Now, all of those terms have something kind of neat. They have a number that comes in front of the variable part, and that's our definition for our next piece of vocabulary. A coefficient. So it's the numerical part that comes before the variable part of a term. So it's the number that multiplies the variables of a term. And let's take a look at some examples of that. So if you have -5x, the coefficient is -5. If you have 3yz's, the coefficient is 3. If you have x squared over 5, the coefficient is 1/5, because this can be thought of as 1/5 times x squared. Those are equivalent. If you have -m, the coefficient is -1. If you just have m, the coefficient is +1. And if you just have a number like -6, the coefficient to that is -6. And this is a special case because there's no variable part. This is a special case, in which case we don't generally call this a coefficient. Instead, we give it a name, and it's called a constant. So it's a term without any variables to it at all. Now, another name for a term is what we're going to take a look at next, and that is something called a monomial. So it is a term, but it is a special kind of term. It's a term that has a number part, we'll call that a variable part, we'll call that x, and it has a power part, n. Okay, so coefficient and possibly some variables. But one important thing is that the power has to be a constant value. It has to be a real number, and it has to be an integer, and it has to be non-negative. So the easiest way of putting all of that together is that this number up here has to be a whole number. And so those are numbers like 0, 1, 2, 3, 4, 5, 6. So no negative numbers, no decimals, no fractions. So examples would be like 3. So it has a coefficient. It doesn't necessarily have to have a variable part at all. It can, so you can have m to the 6th, you can have -3, mn to the 5. Non-examples, you can't have m to the 1/2, because that's not a whole number. You can't have m to the -2, because -2 is not a positive number, so therefore it's not a whole number either. If you have two terms that are monomials that are next to each other, so if you have x plus y, or 3 plus x plus 3, you now have two terms. And when you have one term, it's a monomial. When you have two terms, it has a special name called a binomial. So a piece of algebra where you have two monomials and they're added or subtracted together, so like x is one of them and positive 3 is another one, so you say x plus 3. You now have two terms, or two monomials, and that can be called a binomial. And you can have fairly complicated binomials. You can have negatives in there. All of those are examples of binomials. If you then extend that to three terms, you end up with a trinomial. So if you have something like x plus y plus 2z's, you've got three different monomials added or subtracted together. You've got a trinomial. Past that, so mono means one, like a monocle, a single glass that people used to look through. Bi means two, like binoculars or bicycle. Tri means three, like a triangle. The next thing that you would have four, which might be quadrinomial or something like that. Past three, we just generally say anything bigger than 3, 4, 5, 6, 7, 8, 9 are called polynomials. So a polynomial is a monomial or a collection of monomials added or subtracted together. So all these other numbers that we've seen here, 3m to the 6, negative 3mn to the 5th, those monomials, those are a type of polynomial. X plus 3, y squared plus 5xy, those are binomials. Those are a type of polynomial. Trinomials are a type of polynomial. Above 3 terms, 4 terms, 5 terms, 6 terms, we just call those polynomials. They don't have any other kind of special names that mathematicians generally use. Okay, the next thing. The degree, and really we're going to be talking about two different kinds of degrees here. So the degree of a term we'll do first. The degree of a term is the sum of all of the exponents of all of the variables. And that sounds complicated, but it actually isn't too bad. So if you have 3x squared, you have a degree, so the sum of all the exponents. So here's my exponent, and that's the only one, so this has a degree of 2. If I have a monomial xy cubed, I have a 1 and I have a 3, so this has a degree of 4. 1 plus 3 is 4. So even though this 1 might not be written there, you have to think about that x as having a exponent of 1. So you just add up all the different exponents for all the different variables, and that's your degree for a term. So this works perfectly fine for monomials, for single terms. Let's take a look and see what happens if you have a polynomial. Well, the degree of a polynomial is the degree of the biggest monomial within that polynomial. So if we take a look at a couple of examples of this, if you have x cubed plus 3x squared, well, the degree of this whole thing depends on what the degree of each part is. So you can actually write this out, or you can just think about it in your head. This first term, the total exponents is 3. The second term, we don't even think about what the coefficient is. We just look at the exponents. The degree is 2. And then I look at these two numbers, and the degree of the whole polynomial is the biggest of these two numbers. So I guess what if you have a trinomial or a bigger polynomial where there's a whole bunch of things going on? Well, you just do the same thing. You think about the degree of each little piece. So the degree of this one, the degree of this one, the degree of this third term, and we'll be able to just use the biggest number of those three. So this is 3 plus 1 plus 1, that's 5. 5 plus 1 is 6. 3 plus 2 is 5 plus 1 more is 6. So these are the biggest, so it has degree 6. It's just the degree of the biggest. Those two are tied for the biggest, so it's just 6. Okay, let's take a look at another concept to do with degree that sometimes is a little bit confusing, and that's called degree order. Degree order is a rule used by mathematicians when they state polynomials, just so that all mathematicians in the world are stating the polynomials in the same way. If you have 4 terms of your polynomial, like which one do you write first? Some mathematicians might decide to write them in one order, some other mathematicians might write them in another order, and then they get confused. Are we talking the same polynomial or not? So they agreed upon a convention where they would write the biggest degreed term first down to the smallest degreed term, which is the coefficient, last. So in a lot of examples, that's not going to be too hard. So if I just give you some random numbers here, and you start to go, okay, well, there's 4 terms, so we've got a polynomial, and this one has degree 2, and this one has degree 3, and this one has degree, there'd be a 1 there, and a constant that's basically like x to the 0, because x to the 0 is equal to 1. Don't worry about that. There's no variable part to these. If you have a constant, then it's degree 0, and then you just put those numbers into order. So really we shouldn't be writing it in blue like that. We should make this polynomial equal to the degree 3 thing should come first, then the degree 2 part, then the degree 1 part, and then the degree 0 part. And that's a happy degree order. So the problem, it's not too hard when the polynomials are all different degrees. The hard part becomes when the polynomials start to have the same degree. Like, which one do you write first? So we need a rule for that. And the rule is that if they're tied, use algebraic order. So if you have xy plus 2x squared plus y squared plus y cubed minus ax, if that's what you have, then let's go and see if we can put it into degree order. Well, first we put them into degree from largest to smallest. So this is degree 2, this is degree 2, degree 2, degree 3, degree 2. So I can see which one term comes first. So let me just create some space. And the y cubed is going to go first. But now which of these degree 2 things, I've used up that degree 3 one, comes next? Well, it's alphabetical order. So this is xy. This is really like x times x. This is y times y. That one's already taken care of. And this is a times x. So a comes before the first letter of each of these, x, x, y, a. A comes first. So I put this term next. And it might even be useful to cross off terms as you use them. Then the next one, well, x's come before the y squared, so that term's out. And then you go to the second letter. So it's kind of like looking for a library book. You have to go through all the different call letters. So x's are tied, so you go to the next letter. So xx comes before xy, so x squared comes before the xy term, so I use those ones up, and the only term left is the y squareds. So now it's in descending order of degrees, also known as degree order. It goes 3, 2, 2, 2, 2, all those 2's are tied. The tiebreaker is alphabetical order. This is definitely going to take some practice, and once you get good at it, you'll just use it for grade 9, 10, 11, and 12 and on, just automatically. Super useful for helping us organize some things in the future. Okay, 2 more concepts. One of them is a fairly big one. It's called algebra tiles. And algebra tiles definitely have their own definitions, but basically it's a physical representation of these algebra concepts. So what does an x look like, or an x squared look like, or 2x plus 5 look like? And it's a way of using some tiles to actually model what some of these algebraic expressions look like.